I am Sankita. I'm a member of Women in Cloud Native, and today here we have Mauricio with us from the UK, who is working as a senior software engineer at Diagrid currently. He's also the author of the book titled Platform Engineering on Kubernetes. He's extremely passionate about open source and has worked with big shots like Red Hat and VMware, and is doing great work for the community currently. You all can connect with him on LinkedIn. Actually, I'll tag the link to his profile and his blogs herein. So, Mauricio, over to you. Glad to have you here.
Sankita, thank you very much for the intro. Let me share my screen. And yes, I think that I agree. I'm very passionate about open source because I've been working in open source for a long time now, and it's a pleasure to be here, part of the Women in Cloud Native, webinar. So let's start by introducing myself quickly. My name is Mauricio Salatino. I'm known as Salaboy in the community, and I've been working with open source software for more than 15 years now. It all started more like as a hobby than, like as something that I did after work just for me to learn, and then it became my profession, my professional job, right? Working for companies that were supporting open source projects or companies that were creating new open source projects. That journey led me to today, where I'm working at Diagrid. It's a startup from the US, and we are building cloud native solutions, mostly targeting developers. So if you are like a developer in this space, please go and check the website, check the projects that we are building. And I will be talking a little bit about the Dapper project, the one that I'm wearing the t-shirt here. That is the project that we're working on right now, that it's part of the CNCF, and it's applying right now to graduation process. So it's a very mature project. I think that one of the reasons why I'm here, it's because last year I published this book for Manning titled Platform Engineering on Kubernetes. And so far it's selling very, very good, mostly because I wrote this book with the intention of explaining and showing what I've seen companies, large, small, and medium companies doing when they adopt Kubernetes. I started writing this book before platform engineering was a thing in the Kubernetes space, but at the same time, we have been doing platform engineering for long. So this is basically what I see in the CNCF and in the cloud native space around Kubernetes, and what companies and individuals are doing in order to build platforms on top of something like Kubernetes. So this presentation, while it's about the book, I think that it's also about my learnings and the things that I've been learning by writing a book about Kubernetes and all the CNCF ecosystem, and trying to share with you some of those learnings and some of the resources that I strongly believe that will help you in that journey of adopting Kubernetes and working with Kubernetes every day. So the agenda of the presentation is divided in 3 main sections that I believe that are all related. So basically connecting the dots, which basically means making sure that we understand the space, the industry where these projects are being created and why these projects are created and how we can, make the most out of them. Working with people, because at the end of the day, open source is about people. And then dealing with changes, which is something that I've seen firsthand in the CNCF. I've been working with Kubernetes and CNCF projects for the last 6, almost 7 years. And there is just one constant. Everything changes every day, all the time. New projects come, new projects go away. Projects completely change direction, and you need to get used to it. If you want to build stuff on top of Kubernetes, you need to learn how to deal with changes. So we will be talking a little bit about that too. And because I think that all these learnings are quite important, and also because writing a book about Kubernetes took me around 2 years, I just tried to collect all these learnings into a blog post that I have in my blog. So if you're interested in things like around cloud native, Kubernetes, and open source, you can check it out and then give feedback. This is all about sharing stuff with people, sharing learnings, and then just gathering feedback, and then just improving, creating more stuff. The book, it's not a very large book, mostly because I decided not to include the examples inside the book, right? The book contains basically all the conceptual glue that you need in order to understand the tools that I'm talking about inside the book. But all the examples and all the hands-on tutorials are outside in a GitHub repository. The book is structured like this, 9 chapters, and basically it goes through a story. And again, the story of companies or individuals or organizations adopting Kubernetes as their platform to run their applications, and then trying to go helping individuals into their learning journey, right? So the first thing is, what is a cloud native application? Why do we need platforms? And I tried very, very hard of not creating complicated definitions inside the book, trying to define it as a platform, as a collection of capabilities that you will provide to other teams. And then all those things will only make sense if you understand how cloud native application works and the challenges that you will face when you are building these cloud native applications. So the first 2 chapters are all about that. It's like if you are new to Kubernetes, if you are new to cloud native, chapter 1 and chapter 2 will take you through that journey of, this is a cloud native application, this is how you run it, this is how it works, and this is how it will fail, right? Once you understand what's kind of the end goal of having this application up and running in a Kubernetes cluster, then you can start looking deeper into other things that you will need to be doing, like building containers, like packaging containers and distributing containers, making sure that containers are available, making sure that containers are secure as well. And then things like GitOps, right? Like how many environments do you want? How do you sync the state of an environment to a live cluster? How do you manage all these clusters and all these things? And then applications, business applications are applications, but all the applications, they need infrastructure. They need databases, they need networks, they need, gateways, API gateways, they need security, they need configuration stores, secret stores, message brokers, and a bunch of other things. So we need to learn about, okay, which tools in that space will help us to manage all that complexity and give all the applications all the components that they need. And the first, the first 5 chapters are all about that, about understanding all the things that application will need and the things that you will need to put in top of Kubernetes in order to get all those things. So chapter 6 is all about condensing all these tools together, putting an interface on top of that, like an abstraction that teams can use, so they don't need to learn about all these other tools. Finally, after having some sort of platform with an API on top of it that you can easily consume, I start switching the focus a little bit more on team experiences and developer experiences, where we can help developers to build faster stuff if we give them the right tools. Most of the time, I ask the questions to different companies or different groups working with these tools. Is do you want to really push every developer to learn Kubernetes? Or how much do they need to learn in order to be able to use it and develop their applications? Because there is a fine balance there. You can imagine a company with 2,000 developers. Training every developer to learn all these tools is way, way too much. So last 2 chapters, 7 and 8, are all about that, enabling team to experiment so they can deliver faster, more software faster. And the last chapter of the book actually closes the book talking a little bit about that. There are tons of tools that you can adopt, but if you're adopting tools just for the sake of adopting tools, maybe that's not a good approach. But if you can measure how a tool that you adopt, that you include inside your platform, is actually helping developers or other teams, then you are just kind of in some way protecting your time investment, right? You're adding tools that are actually helping someone and just making things easier for people. So the story of the book is something that you will see if you buy the book, right? But as I mentioned before, the book has a GitHub repository with all the step-by-step tutorials that you can run in your own computers, and that it's completely free and you can use as much as you want. So the first section of the presentation is all about that. It's about connecting the dots, which is the more pure technical thing that I can say here. It's you go to the landscape, to the CNCF landscape, you will see tons of different tools. At first, if you are a beginner or someone new into this space, you will be saying, well, what do I do with all these things, right? How do I make sense of this landscape? Where do I start? Well, it really depends the problems that you're trying to solve. But for me, at least as a Kubernetes user, at the beginning, I thought, okay, if I learn Kubernetes, I will be able to do cloud native applications. But actually, you need to learn about not the entire landscape, but enough to understand which tools are solving which problems, right? So no matter what you're doing, you will have to, run on cloud providers and provision cloud resources, do CI/CD, right? Just doing pipelines for building stuff and then deploying things. You will need to make sure that if you have clusters, you can understand what's happening inside those clusters with observability tools. And finally, and I think that this is important because over the last 2 or 3 years, this is what I've seen more and more, is all about developer experience. It's all about how do we enable teams to build applications, which is basically what organizations are doing, faster without like learning all these tools that are here in the ecosystem. So things that I didn't knew when I started kind of like this journey, and I think that this is like me trying to explain a little bit about like after evaluating 50 different projects from the landscape, right? The most important learnings from me were that, for example, tools are designed with a very specific set of use cases in mind. So you need to be very careful when you say, I want to use this tool to solve this problem that I have in my company, right? Because the problem that you have in your company might not be 100% matching with how the tool was designed to be used. So having a way to look into a tool and understand the use cases that that tool is covering and figuring out the gaps between your use case and what the tool was designed to do is extremely important. And actually, that's where platform engineers nowadays spend a lot of time understanding how tools are designed and then understand how tool A will be integrated with tool B, right? Making tools work together is not as easy as it should. Going back to the landscape, you would expect that if I pick any 2 projects here from the landscape, I will make them work easily because they are all built based on the idea that Kubernetes is some sort of like center of the universe and we should be able to use them together. Well, it's much better now than when I started writing the book, but big part of the book was trying to put tools together, creating some use cases that require more than one tool, and then just making sure that these tools can like talk to each other in the way that you as a user would expect. So that was extremely important, and actually it took me quite a while to get the book right, mostly because of that, right? Like if you go into different GitHub repositories like the Argo CD one, the Crossplane one, and the Tecton one, you will find issues that I created saying, well, for this use case, this is not working as I expected. If I combine this tool with this other tool, well, maybe we just need to polish some edges there because not everything is perfect. So again, as a platform engineer, because you are in charge of combining all these tools, you will need to spend time learning about these different tools and then understanding how they will integrate. Because at the end of the day, you want to do that process so other teams don't need to spend that time, right? Like that's the main point. And for that reason, I created these tutorials that are hosted in that repository, Platform on K8s, under my user. Let me go there. I'm covering more tools than that. I think that I'm covering around like 20 different tools that are kind of like core to the cloud native ecosystem. And again, this was based on what I've seen on companies doing and people adopting outside for their own projects. So let's go to the repository. I just want to show you what the repository is about. Again, it's open source. I have a lot of forks because there is a lot of people contributing to this. And if you are interested in these topics and you want to give it a start, please do so. That helps to raise visibility so other people can find the repository too. And what you will see here is just a repository that contains 9 chapters, like one per book chapter, and it's translated by community members into multiple languages. So if somebody is interested in translating this into a language that it's not translated today, I would appreciate that help, because so far, it has been translated to Chinese and Japanese fully. Portuguese and Spanish and French are now in progress. So, this is like, it doesn't really matter which language do you use. We will try to provide as many examples in all the languages as possible. And it's a community process, so you can join. If you are new to open source and you want to contribute with something, please feel free to reach out here, go to the issues and check the issues for different languages, or create a new issue if you want to translate to a language that it's not there yet. And again, because I didn't knew much of the audience of this webinar, I thought, okay, let's start simple. Let's start, looking into one of these tutorials so you can get an idea of what to expect. Again, if you are like new to the cloud native ecosystem, I think that this tutorial at least will let you copy commands and run in your own computer, run in your own laptop or in your own workstation, and then just go through the exercise of trying different tools out. And the first tool that I suggested to use here, it's Kubernetes Kind, that will let you create a Kubernetes cluster locally. And I can go super simple here and say, let's create the default Kubernetes cluster that Kind will create. But I decided to try some of the resiliency things and just to try some of the core Kubernetes concepts to create a cluster with multiple nodes. So this configuration that you see here basically create a cluster with 3 different worker nodes. That basically means that we will have a Kubernetes cluster with a control plane node that it will run the Kubernetes APIs and some other Kubernetes control plane services, and 3 worker nodes that are going to be used to deploy our application, our cloud native applications. I do this, and then I also install like an ingress controller here, and I have a section for preloading some containers into the cluster. So when you start your application, actually like the application starts fast and it doesn't need to wait for containers to be downloaded from the internet. So the first chapter and the first tutorial is super simple. Install an ingress controller, create a cluster. And then finally, what you do here with Helm, which is another tool for managing packages like Kubernetes packages, that basically are a bunch of YAML files all configured together that you can parameterize. By just running a single command here, you can actually install the application into any cluster that you have. So it doesn't really matter if you are installing this into a cloud provider, into a Kubernetes, like into a managed Kubernetes version running in a cloud provider, or in your Kind environment. Only with this line, you can install a very complex application that will have databases, message brokers, and a bunch of different services all configured together to work. So maybe we can do that, right? I've already pre-created the cluster here. So I can do kubectl, for example, kubectl get nodes. You can see that I have the cluster that I mentioned before with 3 different worker nodes. And I can apply, and I don't have any pods running here now. K is basically the same as kubectl. And I can use Helm, which is, again, a tool that you download, and then you can install packages. You can see that my Helm chart, the package that I'm installing, is it's hosted in Docker Hub, and it's an OCI image. You can just package these configuration manifests for deploying Kubernetes applications as containers as well. And you can version them as well. So if I install this, let's see if it works. Because I'm saying that, let's see if it works, because part of this exercise is for you to go try to do this and then just troubleshoot in case things go wrong, right? In this case, at least the installation step, it kind of worked. It has some links to the repository here, and also some helpers to see if you want to access the application. But because we installed the ingress controller when we created the cluster as part of the tutorial, we can access this application going to just to localhost. But let's check first if we have pods and stuff running. Here you can find like the application services. There are like 4 application services. I created an instance of Kafka, which is a message broker, an instance of PostgreSQL, which is a database, a SQL database, and an instance of Redis, which is a key value store or a cache, pretty much it. I think that's kind of like the application that we have. It's a conference-like application, and I will show you that. But it looks like this. It's pretty simple. We have like a front-end service. We have a call for proposal service, so people can submit their own proposals. We have the agenda service that will list all the submitted proposals and all the accepted proposals. And then a notification service that will be sending emails to notify, if speakers were approved or rejected for the conference. Some services will store data in a SQL database. Some others will store data into a Redis cache, because depending on demand, like if you are like going to the conference, you will have a lot of people looking at what's next. So maybe that's better stored in a Redis database than in a SQL database. And then for sending messages across services, just to communicating different services in an asynchronous way, we will be using Kafka, right? So now that the application is running, because every pod is running there, we can go to the application and look into that. So I went to localhost. That's part of some of the configuration that we applied here in the creation of the cluster, as I showed you before. Here, so we have a bunch of like flags here set. So we can actually use localhost and port 80 to actually access our application. Again, if you're new, you've never done that before, doing all these little things will take you closer to understand how everything is connecting together, how everything is working. So the application, as I mentioned, is just a simple, cloud native conference application that has this form enabled to submit proposals, right? So let's talk about cloud native. Cloud native intro to cloud native. So I'm simulating, someone submitting a presentation, a proposal for a presentation into a conference. And this will pretty much kind of like enable the flow of the application. I've created this application with the intention of giving the readers of the book and giving kind of like the readers of the tutorials an application that already works that they can quickly understand. This application is using databases, message brokers, it's using secrets, and it's using a bunch of different things to give you something that already works that you can quickly understand. So if you want to try tools from the landscape, you can quickly add the tools and change the application, and everything should work. Once we submitted the proposal here, we can go to the back office here, with that arrow here, which is basically how the conference, administrator organizers can approve or reject, different proposals. So if I approve a proposal, I should be able to see that, that the proposal goes to the agenda of the website. So now this is like an approved presentation. I can see that the platform submitted, an email to the person who submitted the presentation saying, your presentation was approved. So congratulations, you will need to perform that presentation at some point. And then the event side of things, every interaction with the platform, every action that the platform executes will generate a new event. So when I submitted the proposal, I got this event created. When I approved the proposal, a new agenda item was created. That's the approval process there. And then the notification sent as well. And again, what I try to do here is just try to have some generic application that you can map to the kind of applications that your company is building with common behaviors, right? Just want to show here that, in the agenda, we can see here the presentation that we submitted and it got approved. If I reject the presentation, it will not appear here. So again, simple application, but from there on, we will use this application to try different tools and to do different things around these application components, right? That's the main point of this. So again, my recommendation, and I think that I have it here in a slide, my recommendation is to try to get some hands-on experience with these tools, right? Even if you don't have any, Kubernetes or cloud native experience, running through these tutorials, installing these tools in your laptop will help you to get closer and gain deeper understanding of what's going on. When you are trying to solve problems, identifying kind of like the problem that you're trying to solve is super, super important, right? Chapter 1 and chapter 2 are not about that, are about like trying to understand the context, trying to understand what a cloud native application is, how it works, and how it can fail. I will not be showing here, but during the book, basically what I do is I go and kill different services, misconfigure some services to see how they will fail, and which ones, you should need to be extremely careful, because if a service like the front end goes down, then no user will be able to interact with your application, right? So that basically push you as like an operator to take certain, initiatives to avoid reaching to that point. But also as developers, you need to build your application in a resilient way that they can deal with these kind of failures. And then, yes, it's all about that. Like, okay, now, what are you trying to do? Which projects are available in the CNCF and even outside the CNCF to deal with some of these things? That's why, for example, as I mentioned before here, chapter 3 will talk about building containers, and the packaging containers and distributing containers. So when I want to install my application in a new cluster, the containers are already available to be downloaded to that cluster. So that's extremely important. And then again, managing environments, creating environments. And then I stopped kind of like on the infrastructure side of things on, okay, like this application here is using like 2 databases and a Kafka broker, right? Where are these hosted? Should they be running here with the application? Should it be managed services in a cloud provider? Okay, let's think about that for a second. What does it mean? Like here, I'm creating a database, it's running inside my cluster. Is that the best way of running this database? Probably for like a database administrator, not the best way. Probably they have instances outside the cluster, right? So how do you help developers to build these applications in their local environments, right? Like in this kind of like local Kubernetes setup, but also to make sure that when they move this application into a production environment, these services can connect to this infrastructure without changing any code, right? Like without requiring like teams to build new images or new containers for these applications to run. All those things are extremely important, and that's kind of like one of the core points there, like in the first 3-4 chapters of the book. How do you tackle this complexity of dealing with multiple pieces, multiple dependencies in this case, that will change depending on where and which environment are you running your application? And that takes me to working with people, right? Like in order to be able to understand and polish all this interaction between, I'm a developer building one of these services, and on the other hand, I have all these operation people and people that it's actually running this in production. How do we bridge the gap between these teams so they can talk the same language while they are collaborating? And on the other hand, also, I wanted to reflect a little bit about how did I wrote this book that it's covering so many different tools, because it would be unfair to say that I just wrote it on my own. I wrote it with community people from all of these tools that basically were validating how I was like positioning their tool, not only because they wanted to see their tool well represented, but also because they needed to validate the use cases that I was using to demonstrate the tools themselves. So one of the things that I've learned by only writing, but also to going to conferences and presenting at webinars and attending webinars too, right? It's about that. It's, if you're doing open source, people is the most important aspect of open source. And you need to understand that most people will work for different companies. So they have like, a daily job that they are doing. But, in open source, we do things because we like doing things, but also because we enjoy collaborating with other people. Nowadays, as you can imagine, we are in a webinar, so people is globally distributed. We need to get used to talk to people from different cultures, from different countries, in different time zones. That's pretty important. And for me, I think that through my career, I just learned to improve those communications. So for example, if I want to contribute to a new open source project, I know how to go there, how to approach these people and get involved with different initiatives. And again, because I work for a company, like, my company, your company, they all have different motivations and goals and why they are interested in open source. So some companies are more, some companies are less interested in open source. But if you're working for a company that's interested in open source, it's much easier, just to go and contribute back. Things that I didn't knew when I started, or at least I was a little bit more naive, right? Like open source is super fun, right? And people do things because they like doing things. But commercial open source projects, they are kind of like different kind of like projects, right? Like because they have somebody putting money and to pay for full-time maintenance. So when you engage with open source projects, and I would assume that most of the CNCF projects, they have some commercial angle, you need to be careful because that's kind of like their job. That's their day-to-day job to maintain these projects. So understanding about why they are doing certain things or understanding where these open source projects are going helped me a lot in my career to understand, how to use these projects in different ways, and also to protect my time investment on these projects, right? If I understand where companies behind the projects are going and what they are doing, I can actually say, I'm okay with adopting this open source project because I see that the company behind is going in the right direction. It's aligning with the kind of use cases that I have and the kind of problems that I need to solve. So I will just jump and help them to go there. For the book, this was extremely important, right? Like understanding which projects were healthy, had strong communities behind, was like the best way for me to say, I can write about this project because I know when the book will be printed, this project will be healthy and it will keep growing, right? And I think that for me was important. I had a situation with 2 or 3 projects that I picked up when I started writing that were not available when I finished the book, right? Like they were closed source or discontinued. So I needed to replace that content. And for me, that was not challenging, but like, it was like a learning experience where I said, okay, now I need to be much more careful when I choose a project and when I choose to contribute to a project, because I want to make sure that I'm spending time on something that will live longer and it will not die in the next year or so, right? And the reason, the main way for me to validate those things behind open source projects and what they are doing is just to understand that, you know, companies behind open source projects are not evil. You know, they are companies. They have some objectives and some goals, but they care about open source. So for me to understand how a company is working and why a company is working on open source, again, helps me to understand how to get involved with the new project and how to contribute back. And for me, you know, again, like that engagement with companies at the beginning, I was much more like naive in the sense of I wanted to contribute to open source. I didn't care about the companies behind the projects. I just care about the people, and I contributed to a project because I thought that it was cool. But you know, if you want to actually create like a more healthy life cycle and feedback loop with these companies, you can go to events and then just engage with these companies to understand what they are doing and why they are investing on open source. And that will help you not only to expand your professional network, but also to gain an understanding about what's happening in the industry. I think that the thing that I achieved the most here with the book was to basically highlight which projects are being adopted before they were fully adopted in the state that they are today, right? When I chose the projects, I had a sense of, okay, these projects and these companies are doing great, so I will include them, and then I will see how they are doing, right? And actually, most of them are super healthy and growing and graduating, for example, in the CNCF maturity process. I had one lesson there, like I think that something that helped me to learn a lot about like these projects and the context and the people behind these organizations and the companies behind these projects is that, you know, it's great because we are all engineers. We can all have a technical conversation and understand again deeply about why these projects were created and what kind of problems they are trying to solve. Because if you look at these three things, for example, Tekton is a very Kubernetes native mechanism, like pipeline engine that you can use. And I cover some examples of this. Then you have other tools like GitHub Actions, which is a managed service running on Azure nowadays to build your applications and to do CI, right? Like you can do CI in the cloud. You don't need to pay for machines or anything. If you are like running some hobbyist projects, that's fine. If you run like a large organization, you will end up paying a lot of money there because everything is managed. And then you have tools like Dagger that it's not part of the CNCF yet, or I don't know if it's ever going to be, but they focus on a different thing. They focused on developer experience and helping developers to build these pipelines as code. So there are like completely three different solutions and completely different like engineering process for creating these solutions and for adopting these and for learning these tools. But having the possibility to sit down with all these communities and see their priorities, where they are going, and specifically which problems they are solving, again, helped me to not only compare these tools, but also make sure that I understand which is the best tool for the problem that I have at hand. So in chapter 3, you can go and try these three things, right? I would assume most people are familiar with GitHub Actions. It's a very heavily documented project. So you can go and just copy examples and check out how to do things. But Tekton, you know, if you don't know Kubernetes, I strongly will recommend you to check Tekton and how it works, because for platform engineers trying to create their own libraries of pipelines in a very Kubernetes native way, that might be the tool for them to go. And if you want to run pipelines everywhere, right, like something that doing with GitHub Actions is not that easy, just to run a pipeline in your laptop, for example, Dagger might be a solution that you want to check. Again, completely different solutions. They are all in the CI space, and then you can decide what actually will benefit your teams the most. And I think that that's extremely powerful. That's the extremely powerful, you know, advantage of learning different tools to be able to compare them. And then when you have a problem, then you know which one to recommend to your teams or which one to add to your platform initiatives. So again, if you want to learn, if you want to learn from open source projects, you just go to open source projects and talk to people there. Again, just engage, provide feedback, use tools, build proof of concepts, and get more insights about how these tools work. So then you can not only recommend to your company and adopt for your personal projects, or just build into your platform initiatives. And again, don't be shy. I think that that's the most difficult part for people, just writing an issue in a GitHub repository or going to Slack and just chatting with people that you don't know. But most people there, like on open source projects, they are welcoming and happy to help new people to get started. I always say in my presentations, and that's why I get I get a lot of emails and a lot of messages as well, that I'm happy to mentor people to get started in their open source journey. But I truly believe in that, because if I help someone to get started, that person will help someone else. And we can be all learning from each other, right? Probably if I help someone to get into open source, I will be learning something from them that I didn't have the time to learn before, or maybe I wasn't interested and now I learned something new. So if you are into open source already, try to help someone new. If you are not into open source yet, feel free to reach out and we will help you to get started for sure. And talking about that, I think that that's one of the things that I wanted to mention in this presentation, is that there is different working groups inside CNCF. So if you are new to CNCF, if this is your first CNCF webinar, you need to understand that there are different self-organized working groups in the CNCF with different topics, right? There is a platform working group, and there is an application development working group where I'm heavily participating nowadays. So if you're interested, on these working groups that are open, everybody from any company can join, and then we will just collaborate into helping developers get closer to cloud native development and the tools that are in that space. You can just go to that URL and sign up for our bi-weekly meetings that we meet every 2 weeks, and we are just working on some things to present at KubeCon, right? Again, if starting your open source journey doesn't happen in a concrete project, it can happen in one of these working groups where you will meet people that will guide you to which projects you might be interested to contribute in the future. So again, please check it out. If you have any questions, I will probably share the link as well in the chat and also in the recording, because I think that that's a very great entry point for people that it's new to CNCF, to join some of initiatives and then just get involved with something that definitely it's a learning path. It's not like work. It's where we go to learn and to share with other people, and you can get up to date on what's going on in the industry with that. And then finally, what I mentioned before, writing a book, it's all about dealing with changes, because when you start writing a book, you know for sure that things will change. So you need to adapt and then make sure that you have the right way of describing the problems that you're trying to solve. And a way that developers deal with change is making sure that you have the right APIs, the right interfaces. And if you're a platform engineer, you are pretty much doing the same. You are creating interfaces to provide solutions or capabilities for your teams, no matter which tools are you using to implement those behaviors or those capabilities. Sometimes what we do is we try to use that principle of delaying the decisions. So if you delay the decision of which tool are you going to use for a certain problem, and you create the right API in front of the problem, then you will just give your team your APIs, and then you can swap out different implementation details later on. In the book and in that blog post here in the Crossplane community, that's something that also got created based on the book content. I talk a little bit about that, about Crossplane is a CNCF project that will allow you to provision, cloud resources, and exposing different interfaces for simplifying the provisioning of complex infrastructure. So as a developer, you can say something like, I want a database, and then you get a database, no matter if that database is hosted in AWS or in Azure or in Google Cloud, or if it's an on-prem database, right? And on the other hand, you have tools like Dapper, the project that I'm working on right now, which basically give you APIs for developers to use. So if developers want to implement an application that will run on different cloud providers, you better give developers the right APIs and then enable the operations teams to configure those APIs to connect to different infrastructure, if they are running in production or if we are running in one cloud provider or another one. So that's pretty much what Dapper is doing nowadays, is giving developers functionalities, right? And capabilities as well. The same way that platform engineers will give teams capabilities, Dapper is giving developers APIs that implement different behaviors. So applications will store data, send events like in the application that I showed you before, the conference application. and doing workflows for orchestration across different events and implementing resiliency patterns, implementing observability and all these things. Dapper actually provide all these things in a nice way for developers. Things that I didn't knew about this, and let me show you a little bit of that first. Before jumping into that, I just wanted to show you how that chapter 7 looks like, which talks about that. Like, let me show you two things. So I will show you first the crossplane one. So this is the provisioning, infrastructure using crossplane compositions. And with crossplane, you can do things like this, right? Like you can create a new Kubernetes resource that basically will represent the database. You don't know where that database is hosted, in which cloud provider is hosted. The only thing that you know is that you want a small database because you are probably doing some development task, and you have some other like ways to say where that database is in a way that I don't need to learn about like how to connect to AWS, for example. I just want a database. Give me a database. If I send this request to the platform API, I will just get a database that my application can use. So that's kind of like a way of creating interfaces or like simplified resource for Kubernetes users if you are exposing the Kubernetes API for your platform. If you are on the developer side, that's a little bit different, because as a developer, what you want to do is you want to call APIs from your applications, and that's pretty much what Dapper gives you. So Dapper is a project that you install in your Kubernetes clusters, and you can use to give your applications these APIs to perform different operations. So the tutorial here, the step-by-step tutorial, basically shows you how to transform the application that we were running before into an application that consumes the Dapper APIs. And the Dapper APIs, the only thing that they will do is they will put an interface that we call components here. It put an interface behind your application and in this case, the message broker or the databases, right? So at the end of the day, the application calls an API instead of calling Kafka directly or Redis directly, right? You can use something for PostgreSQL too here. The idea here is that then you can swap Redis and Kafka for a managed service without changing any of your application code, because your application will be relying, on a standard interface. And if you look into here, like the source code here, it shows pretty much how the API looks in Go, but Dapper provides SDKs into different languages. So you can use any language, any programming language that you want, and your applications can be moved into different environments. For example, here I'm showing that you can deploy exactly the same application using the Dapper APIs and connecting that into, for example, Google managed services like Google PubSub for messaging, or Google GCP in memory store if you want to use like a distributed cache like Redis. No changes in your application, only changes in configuration when you deploy this application. And the APIs are pretty simple, like getting a state like that you stored somewhere, or saving state, or publishing and consuming events is something that a developer can quickly learn, because again, they're just APIs, and developers actually know how to consume APIs. So that's kind of like what Dapper is doing. And also, like, just to demonstrate that it's not only a Dapper thing, other projects are doing things that follow the same approach, like open feature. So feature flagging is another thing that as a developer you might want to, like as a developer or an organization, you might want to use to improve the delivery speed for your services. The idea is that you will have flags that will enable you to turn on and off different features from your application. And that's basically provided as a functionality in open feature SDKs. So as a developer, you will include this SDK, and then you will evaluate if these flags are on or off, or if they have certain values. And the idea here is that you can keep releasing new versions of this service, and then the product team, the product manager that defines now this feature should be enabled, or we want to try these features with only beta testers, for example, will go to the dashboard and turn on that feature, so certain users can actually see that feature and try it out. If everything is all right, then that feature can be enabled for everyone else. So open feature basically implements the same pattern. It's like a standardized interface for consuming feature flags and to configure like feature flags. And you can use it in the same way from any other language, because they provide like SDKs in different languages as well. So in this kind of like hands-on tutorial, you try two things. You try Dapper for APIs for developers, but also you try feature flagging using open feature and following kind of like the same pattern. And on the book, it's more about like which other tools follow the same pattern, and why, even if you don't want to use Dapper or Open Feature, following these patterns makes kind of like a lot of sense, and it will save you a lot of time when you build complex applications with tons of different distributed teams. So to close down on these things that I didn't know when I started, I think are extremely important. It's like choosing a cloud provider, like let's deploy our application in Amazon or Azure or Google Cloud, or definitions like which database should we use? Should we use MySQL or PostgreSQL or Redis or MongoDB or whatever, or Kafka or Pulsar or RabbitMQ? All of these things are very binding contracts. The moment that we make one of these decisions, it's very difficult to change later on when you already have teams building services against this infrastructure. So having the right APIs between these decisions, behind these decisions, is extremely important. So as soon as you get used to just consume a single database, then your developers will get too familiar with that, and changing that and retraining developers to use a different solution might be too hard. Instead, if you give them APIs, then behind those APIs, you can change implementation details. And this becomes really, really important when you have 2,000 developers, right? If you have 3 developers, then they have full control on everything. Having APIs at that level doesn't make sense. But if you have larger and larger teams, this becomes a really time saver for your organization. So think about this. Remember that for Kubernetes is the same, right? Like you can just go and use Google Cloud providers like Google Cloud without Kubernetes, because it might be easier to learn. But if you start having more and more teams, you want to standardize. That's why Kubernetes and the Kubernetes APIs became so important in the industry. So check, if you haven't seen Dapper, check the tutorial there in the repository, check the other tutorials, because again, APIs, I think that now in the industry, we will see again this big shift of let's focus on developer experience. And the way we do that is by having the right APIs in place for them to go faster. Some tips just to finalize the presentation, and I will be more than happy to take as many questions as you have, is that make sure that you have the right interfaces. Make sure that when you adopt any of these tools that I mentioned before, you evaluate these tools for your use cases, but also you look into how customizable they are, right? Like how much can you change this tool? Because if you don't have the right hook points or the right customization mechanisms, you will be probably covering 80% of your use cases, but that last 20% will be really, really hard to change or to adapt for your organization. So just always check that. Always ask yourself, how is this project going to work for local development? Because most developers, unless they are using cloud IDEs or cloud environments, like fully cloud environments, they are used to work locally, like in a local development, inner loop. So how all these tools are going to work for your local development practices? If you have, again, 2,000 developers, you need to answer that question pretty early on. Because if you give them tools that they cannot use locally, it will complicate their lifecycle, their workflows. And yeah, and look into tools that provide ecosystems, right? Like I think that became way much more important for me in the last 2 or 3 years. When I evaluate any of these tools, I look at tools that have marketplaces, or that they have community-driven integrations, or catalogs with pre-made configurations of patterns, right? Where I can see, if this is the use case, this is how I configure the tool to work for that specific scenario. And I think that the most mature open source projects, like in the CNCF, they are starting to include these things. So check all these things, because these things are extremely important. Collaborations and marketplaces are great. When you see that, that's a sign that they have a healthy community and a lot of companies contributing back with their, with their requirements or with their own integrations. So I talked a little bit about connecting the dots, making sense of this super large ecosystem that we have in the cloud native space. Working with people, you need to make friends in order to understand this super large industry. Understanding every project on your own is super hard. You can always connect with people that has been doing kind of like the specific thing that you're doing for a long time. And dealing with changes is key here for success, right? Like you need to learn to understand that things will change. No matter which decision do you take today, tomorrow you will need to change it. And you need to understand to evaluate how hard it will going to be to change later on. So check the repository. If you like it, please drop me a comment or just a star, or just fork it and contribute with the language translation, or whatever you think that we can do in order to make it better. Let me know. So if you have any questions, please, I think that this is the right time to ask. And yeah, thank you for listening.
I see Abhishek has a question.
Yeah, sure.
Hi, Mariko, and it was a great enlightening session. So,
Thank you.
my question is more specific to the selection of tools. Every organization has their own personal favorites of how it has been engineered or architected in terms of devising a load balanced or an open source solution. What would be your
Mhm.
recommendation to help the decision makers, let's say the leaders, the engineering managers, to probably tell them about number one, a cost effective solution, number two, a scalable solution? What would be your approach? What would you recommend in such scenarios?
So it really depends on, like, if you are evaluating only open source tools or if you are evaluating commercial offerings, right? Like if you are like a large organization, you will probably look into some open source tools, but then you will look into the commercial offerings that are offered on top of those open source tools, right? Uh, and I think that goes back to the point of engaging with the companies behind the open source projects, right? I work for a company that works on open source, and for me, the best way for me to evaluate other companies is to go straight to the companies and basically ask them questions, and also see around in the community who else is using those solutions, right? The book, it's covering tools that nowadays are well recognized and have companies behind them that can provide you support and can provide you kind of like use case, like case studies of who is using this and what's the scale. And the CNCF does a lot of work around that too, right? Like if you look like case studies in the CNCF, you will see, Argo CD being used by this company with 1,000 clusters, right? And I think that would be my main, information access point to validate these decisions. It's hard when it's generic, like the question is generic, right? Because like there is no single way of saying this tool is good. So you really need to understand what's the problem that you're trying to solve, the scale, right? Like how big the problem is, and if there is money involved, you need to engage with a commercial offering for sure.
Right.
I hope that makes sense.
Yeah. Thanks, Monica. Thank you
Thank
for
you.
the.
Thanks, Mauricio. I think that was such an insightful session. I mean, you just not just talked about the tech part of what goes on in the different companies, but then you also explained the people part, which I think plays a very important role when we talk about open source and giving back to the community, right?
That's it.
Yeah, that was so awesome. I think all the people who have joined us today, you guys have taken something back from the session, and go and check out his book. Obviously, I'm gonna link the description of the GitHub link down below.
Yep.
And yep, anyone having any more questions? We're going forward. One,
Don't be shy.
two,
Yeah. Good stuff.
yep.
Good. And always, like, again, just check the tutorials, right? Like those are free, just go through them. And then I think that like when I'm trying new things, that's the moment where I came up with questions, right? When I look at the presentation, maybe I cannot figure out what to ask, but when I'm trying a tool and nothing is working, that's the perfect place to ask questions. So if something fails, please feel free to reach out and I will be more than happy to help.
Also, we're trying to build a sort of a very supportive community out here so that everyone can actually go forward building the stuff that may or may not be existing and a better, more efficient version of the same. So,
Yep.
all right, I don't see any more questions.
Great. Thank you
Great.
very much for attending, everyone.
Yeah. Thanks, everyone, for joining the session. Thanks, Mauricio, for joining with us. Thank you.
Thank you. Thank you.